Good morning, everybody, and welcome back to Computer Science 150. It's been a little while since we've had a lecture, so we need to start with a little bit of reminder of where we are in the process of learning Java. Uh, Starting last week and continuing on into Monday of this week, we started to have an introduction to working with objects in Java. And there's a series of lecture notes posted on the website covering those lectures. The first lecture is lecture 14, Introduction to Objects, where I introduced some basic concepts surrounding objects, including member variables and constructors. Then I showed on Monday an extended example of the guessing game. And the new thing introduced in the guessing game example was the use of methods in an object to help uh, carry out whatever activities the object is going to carry out. And then also at the end of the lecture last time on Monday, I gave a brief introduction to the very important ArrayList class in Java, which is a very handy class for storing lists of objects. And today's example is going to be making use of that particular class. All right, so today's lecture is going to be covering an extended example. And the main goal of today's lecture is to talk a little bit about the process of designing objects. Because when you set out to use objects in a program, you have to make several decisions about what goes into those objects. You'll have to make decisions about what the member variables should be, and you'll also have to make some very important decisions about what methods the objects will need to have. All right, so we're going to be doing that today with an extended example. Over the course of this example, we'll walk through a process for discovering what methods classes need, and we'll put together an entire extended example using objects. Now, since we're also on the topic of objects, you should be doing some reading in Chapter 9. And following our usual pattern, I also have posted a programming exercise that comes from Chapter 9. This is exercise number 13 from the end of Chapter 9. And following our usual procedure, this is going to be assigned today, and it will be due by 5 p.m. on Tuesday of next week. All right, so let's dive into the specifics of the example that we're doing today, starting with a description of the problem that we're going to be solving in today's example program. All right, the problem that we're solving today is the produce tracking problem. This is basically a very simple inventory management problem for a small business. Right, so the story here is we're pretending that we're running a small produce warehouse, and the produce warehouse stores and ships various varieties of produce. And what we need to construct is a simple inventory tracking program that will allow us to track produce as it comes into and out of the warehouse over the course of the day. All right, and the raw material for this program is going to be a text file that contains information about what items are in the warehouse and over the course of the day, what things go in and out of the warehouse. And the goal of the program is to track all of the changes in the produce levels over the course of the day, and at the end of the day, print a report of exactly what items are in stock and how much of each item that we have in stock. The numbering system here is that everything is recorded in terms of cases. So here it's saying at the end of the day, we were left with 42 cases of apples, 24 cases of lettuce, and so on and so forth. All right, so our primary job is to write a program that can read the initial input text file, which has information about how many cases were in stock at the beginning of the day and how many cases went out or came in over the course of the day. And then at the end of the day, print a summary of what is actually in stock at the end of the day. All right, so that's the problem that we're going to be solving. And the purpose of today's example is to take you through the process of designing a collection of objects for the purpose of solving a particular problem. And again, this is the problem we're going to be solving, reading this text file, processing the information in the text file, and then printing a report of what items are in stock at the end of the day after a bunch of things have gone in and come out. Okay, so if we're going to write a program to track this information, the first step is identifying different classes that we're going to need. And because this is a fairly simple program, we are going to be able to get away with using only 2 classes. Here's the structure of the first class we're going to work with. This is a class that's used to track a particular item in the warehouse. And items have 2 relevant things attached to them. One is that every item has a name that we use to refer to that item. And then secondly, every item has a quantity. This is simply how many stocks, how many cases of that particular item we have in stock at any given time. Right? And the first step in making an object is deciding what data that object stores and providing that object with the relevant member variables so it can store the relevant information. Right? And here, since we've identified that each item has to have 2 pieces of information associated with it, the item's name and its quantity, that then causes us to add these 2 member variables to the class. And then another thing that you should do immediately as soon as you have identified the member variables that are going to go into a class is you should also provide a constructor. Right? Again, remember that the purpose of a constructor is to initialize the member variables. The constructor has the same name as the class, and it will be basically initializing all of the member variables. All right, also, when you are writing a constructor, you also need to think about what information is going to be provided at the instant you create one of these objects. And since we can pretty much count on each object having a name as soon as we create it, that's why I provided a single parameter here that would allow you to pass in the name of the object. It would then take the name that you would give it, save it in the member variable, and then automatically set the quantity to 0. Because until we learn otherwise, that's the starting quantity that we start out for each of the items in the warehouse. Okay, now, and eventually, we're going to be adding more things to this class. The main thing that's missing now is methods, because to operate with the data that's in this class, we're going to need to add some additional methods. But rather than do that at this point, I'm going to be putting that off until a little bit later in the example. Eventually, we'll come back and revisit this class and add some additional methods to it. Right? But for now, this is the initial structure of the item class. Each item object represents a particular item in the warehouse, and it has a name and a quantity. All right, now, we're going to need a second class to solve this problem, and that second class is the inventory class. And the primary purpose of the inventory class is to keep track of all the different items that we have in the warehouse. All right, and since that pretty much is going to involve storing a list of things that we have stored in the warehouse, we need some sort of obvious way to store the list. And I'm going to follow the practice that I'm going to be using quite commonly whenever I'm working with objects, and that is when I'm working with objects, by far the most convenient way to set up a list of objects is to use an array list object. All right, so that's why I've added as the member variable in this class an array list of items. This is where we're going to be keeping track of all the items that are in stock in the warehouse. And as soon as I've identified that as a member variable, I also need to go ahead and write a constructor that will be responsible for initializing that in the first place. And again, since the array list is an object, the way that you typically initialize objects is by using the new operation, right? So this is how you would create a new empty list of items to go into your warehouse. Okay, now also here, you'll notice that this is the only stuff that I've added to the inventory class so far. Eventually, what we'll also need to add to this class is some methods that allow us to do things with the inventory. But again, that will come a little bit later in the process as we discover the need for those methods. Okay, so let me pause here briefly and ask if anybody has any questions on either the item class or the inventory class, because these are the 2 key classes we'll be working with in the exercise. Okay, now as I mentioned a minute ago, the most important thing that we're going to be doing to fill out both of these classes is we're going to have to carry out a process whereby we discover methods that need to be added to both of these classes. And eventually we will end up adding several methods to both the item class and the inventory class. What we need, however, is some sort of a systematic and rational process for discovering what methods we're going to need and then going ahead and adding those methods to these classes. All right, now what I'm about to show you is a strategy for writing an object-oriented program. And the purpose of this strategy is to help us with this question of what methods do we need and what should those methods do. All right, now this is a very commonly used strategy in programming. In fact, it's so commonly used that it has a name, and that strategy is known as top-down design. Right? And here's the basic procedure whenever you're doing top-down design. If you're going to be writing a program using the top-down design strategy, the starting point for your work will always be the main method in the program. Right? And the reason why that is a good place to start is that in the main method, you'll get sort of the big picture view of what's going on. Because the main method is always the starting point for every program that we write, and it basically is responsible for carrying out all of the major activities in the program. The main method is always a great place to start writing the code for your program. Right now, what I'm going to be doing in this main method is I'm going to be outlining a series of major steps that need to happen. And as I go through this process and as I work my way through the various things that need to be done, one of the things that I'm going to be looking for is opportunities to discover methods that need to be added to my classes. Okay, so here is the main method that I've ended up writing. It might be a little bit more convenient to view this main method over in NetBeans, because NetBeans will give us a nicer view of what's going on. So let me go ahead and show you the main method for the produce tracker here in NetBeans. Okay, so what needs to happen in the main method? Again, we need to keep sight of the big picture here, and the big picture is that what we're going to be doing is we're going to be starting by opening up this text file that has information about what's in the warehouse and what goes out of and into the warehouse over the course of the day. And our main piece of work is going to be involved in reading the information in this text file and making the necessary changes to the inventory as we go along. Right? And the other major requirement is that when we have read all of the information from the text file, what we want to actually spit out at the end of the day is a list of all of the items that are in stock and how much of each item that we have. Okay, so with that big picture idea in mind, let's now walk through this main method line by line and see what it's doing. Okay, so the first thing is, since we're going to be reading information from the text file, what we have here, some pretty familiar code. This code is responsible for opening up a scanner that will allow us to read from the stock.txt file, and this is where our information will come from in the first place. Now, the next thing that will happen is, as we start reading information from this file, we're going to need to want to make some changes to the inventory. So the first step in getting ready to do that is to start by creating the inventory object. And here's the typical syntax that you'll use for making an object by using the new operation. Remember, what the constructor for the inventory class does is when you create an inventory object, it basically creates an empty list inside the inventory object, and then we will begin filling that list with items as information comes in from the text file. Okay, now the next major activity that we're going to be doing here is we're going to be reading input from a text file. So what follows is a fairly typical sort of loop that you are getting used to seeing that shows up anytime that you are reading information from a text file. It's a while loop that basically says, as long as the input scanner still has more material available for me to read, I'm going to go ahead and read some more material and process it. And on each trip through the loop, we have to read information, one chunk of information from the text file. And since the text file is organized as a series of rows, and each row has a command, the name of an item of produce, and a number on it, this is how we're going to organize the code that reads the data. It's basically going to operate by rows, and for each row that it reads, it's going to read the command, the name of the item, and how many cases are involved. All right, now the next thing we have to do is looking at these lines in the text file, you see that there are different actions that may need to be performed. One of these actions is putting a certain item in stock. Another action is taking so many cases of a certain item out of stock. And a third action that we'll have to process is adding new cases to an already existing item over the course of the day. All right, so each time we read one of those lines, the next thing we need to pay attention to is what is the command that we just read. And there's three possibilities. It can either be the stock command, the in command, or the out command. And to help us process those three different possibilities, I've set up a chained if-else statement that checks to see what the value of the command variable is, whether it is stock, in, or out, because those are the three cases that we're going to encounter. Right now, once we know what the line of code from the text file wants us to do, the next thing we'll need to do is we'll need to tell the inventory object to carry out an operation that matches the command that we've been given. Right. So, for example, if the command is we want to put a certain item in stock. Right. In that case, we know that what we need to do is we need to take the item with this name and add this many cases of that item to the inventory. And to make that process easier, I've imagined adding a method to the inventory class that would make it possible to do that. Right. So here's the first case where we've discovered the need for a method in one of our classes. What I've just discovered is that I have discovered the need for a method called add items. And we'll be using this method anytime it's necessary to add a certain number of cases of a particular type of produce to the inventory. All right, so that's the first of the methods in the inventory class that we have discovered the need for. All right, and it turns out you can use that same method for both the stock command and the in command, because in both of those situations, essentially what we're doing is we're adding more cases of something to the inventory. And the same method can handle both of those scenarios. All right, and the final case is the case where stuff is going out of the warehouse. And for that, we've discovered the need for a second method in the inventory class. This will be a method called remove items. And its purpose, of course, will be you'll tell it what type of item you're removing and how many cases you're taking out of the inventory. And that method will handle the work of doing that. All right, and then finally, the last thing that happens in the main method is once we have processed all of the data that comes in through the text file, the last thing the program has to do is it has to print a report at the end of the day saying how many items, how many cases of each different item we have available in stock at the end of the day. Right, so here's another instance where we've discovered the need for a method. Since the inventory class has all of the information about what we have in inventory, the inventory class is the obvious player in this program that can handle the responsibility of printing the report. Right, so here I've discovered the need for a third method in the inventory class that will handle the work of printing the report at the end of the day. Okay, so this is the first thing that happens in top-down design. We start out by writing the code in the main method, and we sort of outline the major steps that need to be performed. And the most important thing happening here is along the way, we are discovering the need for additional methods that need to be added to some of our classes. Right, so, and in each case, we have a rough sense of what we want these methods to do. And with that rough sense, we're then going to go to the inventory class and fill in the details of these methods. Okay, but before I do that, let me pause and ask if anybody has any questions about the main method that we're looking at here. Okay, now one final remark about this. Another thing that I've done here, and this is on purpose, is of course, anytime that you write a main method, that main method has to go inside of a class. So one of the other things that I've done in this program is I have actually created a third class, and the only purpose for this third class is this will give us a place to stick that main method. One reason why this is a good idea to do is that we could conceivably have put this main method in one of our other classes. For example, it would also make sense to put the main method inside the inventory class. But the problem with doing that is as soon as you put that main method inside a class like the inventory class, which already has a bunch of stuff going on in it, that tends to make the inventory.java file longer and longer. And anytime a source code file gets very long, it becomes awkward and hard to work with. Right, so here, simply as a strategy to make the inventory.java file shorter, what I did is I made a separate class, and the only purpose of this class is to give us a home for the main method. Right, this is a perfectly legitimate thing to do. We have a third class now where the main method appears, along with the other classes that we are going to have in our project. Okay, so now let's move on to the inventory class. Let me go back to my slides here, and let's go through the process now of writing the code for each of these three methods that we have discovered a need for in the inventory class. All right, so here's the first of the three methods. This is the add items method. And again, from the way that I use that method in the main method, we know that anytime we call the add items method, we're going to be passing it two pieces of information. One is the name of the item that we're adding, and the second is a count of how many cases of that particular item we're trying to add to the inventory. All right, so that sets up the structure of the method. This is now going to be an ordinary non-static method in the class that has two parameters. One is the name of the item that we're adding, and the second is an integer telling me how many cases of that item we would like to add. Okay, now the other thing we need to bear in mind anytime we start writing methods for this class is we also need to keep in mind the overall structure of this class. Right, and again, what's going on in the inventory class is that there is only one member variable for us to work with. It's the thing called stock, and that is the list where we're going to be storing all of the items that are in inventory in the warehouse. Right, so if we're in the business of adding new items to the inventory, essentially what we're going to be doing is we're going to be creating item objects and adding those item objects to this stock list that we set up in the inventory class. Okay, so here now is the code for the add items method. The first thing we have to worry about is that there are actually two different scenarios that this method will have to handle. One scenario is the scenario in which we already have a certain quantity of this item in stock, and all we're doing in that case is simply adding more cases to what we already have in stock. The other scenario is the scenario in which we don't yet have this item listed in stock, and we need to create a new object for it and put that object into our stock list. All right, so what we need here is some logic to help us to distinguish between those two cases, either adding to an existing item or creating a totally new item. So we're going to need a simple if statement here to distinguish between those two different scenarios. Okay, now the main way that we're going to distinguish between those two scenarios is by asking a question. And the question is, do we already have some of this particular item in stock? Okay, now if we could conceivably have written some code here in this method that would actually answer that question for us. But in order to keep the code for this method shorter, the strategy that I have chosen to use here is I've decided to write yet another method for the inventory class that will answer that question for us. Okay, and so what I'm imagining doing here is I'm imagining adding another method to the inventory class. This method is called exists. And the way it works is you'll pass it the name of an item, and it will answer the question for you, do we already have some of this thing in stock? and it will give us back either a true or false answer that we could use in an if statement to distinguish between these two scenarios, either adding to an existing item or having to create a completely new item. Right now, if the exists method tells us that this thing does not yet exist, we don't have any of these things in stock, what we'll have to do then in this second case is to create an item object to represent that thing, and then modify it in the appropriate way, and then go ahead and add that item object to our stock list. All right, so that's going to require creating an item object, giving the name of the item. Then, since the item objects all start out with a quantity of 0, we're going to need to have some way of telling the item object that we're adding this many cases to the item. And for that, we're going to imagine adding another method to the item class that will do that. Right? And then once the item has been set up correctly, the only thing left to do is to go to the stock, which is an array list, and use the add method to add that new object to the array list. And we then have successfully put that item into stock. All right, and then the other scenario is the scenario in which we already have some of this item in stock. This item already exists in stock. So in that case, what we need to do is find the object in the list that represents that item, and then tell that particular object that it needs to increase its quantity. Right, now here, yet again, is a scenario where we need to do some work with the stock list. We need to figure out where the item is in that stock list and get that object. Well, once again, to make my life easier, I basically have passed off that bit of work to another method that I'm going to be adding to the class. All right. In fact, this is a strategy that I tend to use pretty extensively. Anytime that I imagine writing a piece of code that does anything that looks remotely complicated, I am very enthusiastic about passing the buck and passing off the work to another method. Right, so here in this method where we discovered the need to ask a question, does this item exist already? And then if it does exist, can you find it for me? Because those are both moderately complex tasks, I'm going to pass the buck here and say, well, what I'm going to do eventually is I'm going to write some methods that will do these things for me. And all I need to worry about at this point is simply calling those methods. Because by being able to call those methods, they will make my life easier when it comes time to write the code for this method here. All right, so this is another aspect of top-down design, and that is as you dive into the details and as you start writing individual methods in your classes, along the way, you may discover the need for additional methods. Right, and this is essentially the process whereby we discover all of the methods that we're going to need as we work our way deeper and deeper into a project. Okay, so that is the add items method. And once again, let me pause here and ask if anybody has any questions about how adding items is going to work. Okay, so let's see what we've got next. Since I just discovered the need for a couple of additional methods, let's go ahead and take care of those methods right away, because these are each individually fairly short and simple, and we can quickly go through the exercise of writing the code for these things. Right, so what I just discovered in the last method is I'm going to need two additional methods in the inventory class. These are what are technically known as helper methods. Because they basically help one of our methods do its work. And a widely used convention that people follow when they are writing helper methods is they declare these helper methods private instead of public. Most ordinary methods in a class are typically declared public so that you can call these methods from anywhere that you like. But in the case of helper methods, which are meant to be used internally inside of a class, they are very often declared private. Because they are literally for the private use of the inventory class itself. And these are methods that are going to be called from other methods in the inventory class, and they're essentially private to the inventory. Okay, and here's the logic for both of these. The exist methods, what it's supposed to do is you give it the name of an item you're looking for, and what it's going to do is it's going to basically scan through the list of available items looking for a particular item with a particular name. Right? And the way that we do this is we write a simple for loop that goes across the array list. You can access individual items in the array list by using the get method. So this will get one of the items from the array list. And then what we have to check is we have to check to see whether or not the name we've been given matches the name that's stored inside this item. All right, well, once again, I'm going to imagine using a method in the item class to do that. Imagine adding a method whose name is called isMyNameThis. And if the name of that object matches this name, the object will say true. And at that case, we can stop and say, aha, we found the thing we're looking for because we found an item somewhere in the list whose name matches the name that we've been given. So at that point, we can immediately stop and return true because we've established that this item exists in the list. And if we make it all the way to the end of the list without having found that item, we have to have no other option but to return false at the end of that by saying this item doesn't exist in the list. All right, and then very similar, we have a find method. The purpose of this find method is to locate the item with this name. Has a very similar structure. The only difference is when we find an object that says, hey, my name is this, we immediately return that object because that's the object that we're looking for. All right, and to handle a scenario where we don't find an object with the name that we're looking for, what you typically do in a method that is designed to return an object, if you can't find the object you're looking for, what you return instead is this special null value. Null is essentially the universal thing in Java that's used to indicate that nothing is there. Right? So if you find no object with that name, you're supposed to return null from this particular method. Right? So those are the two helper methods that will help the add items method do its job. Okay, now the next item that we need to work with is the remove items method. The purpose of this method is to, you mention the name of one of the things that we have in stock, and you'd say, I would like to remove this many cases from our inventory of that thing. This is the method that will do that work. Right now, again, I'm going to take advantage of the fact that we have these helper methods now to help me do my work more quickly. So now, as soon as somebody mentions the name of an item, I'll immediately turn to this find helper method and say, hey, go and find me the object that represents that item. Right? And then once we've found that particular object, we then will tell it to decrease its quantity by this amount. And then as soon as we do that, there's always the danger that we have shipped out the last case of that particular item. So what we'll need to do after decreasing the quantity is we'll need to come back and ask the item, are we now in a state where there's nothing of this item left? And if we reach that state where we have 0 cases of a particular item left, what we're going to do is simply remove that item completely from stock. And for that purpose, there is already a handy method in the ArrayList class. It's called simply remove. You give it the object that you would like to remove from the array list. It will then locate that object and pull it out of the array list and remove it. So that item is now gone from our inventory as soon as we've shipped out the last case of that particular item. Right, so that is the method for removing items from the inventory. Right, and again, one other thing that we're discovering as we go along, as we do various interactions with these item objects along the way, we are discovering more methods in the item class that need to be written. So eventually we'll need to go to the item class and fill in all of those methods as well. Again, this is another key part of top-down design. Very often as you start writing the code for one method, you discover the need for additional methods that will need to be written somewhere else. This is a very important thing that happens in a top-down design process. All right, and then the last major method that we need to add to the inventory class is the print report method. And the purpose of this print report method is to basically print the final report at the end of the day. And that report is basically a list of all of the items that we have in stock and how much of each item that we have available. Right now, again, this is going to involve simply writing a simple loop that goes down through the array list. And then for each item that we come to in the array list, we'll pull it out of the array list by using the get method. And then we'll need to do something to actually print this item. Right now, to actually print the item, I'm going to be using a somewhat specialized trick that you can use in Java. And that is, I'm simply going to be passing that item directly to a print command. Right now, normally when you do that, this won't work well. This won't work correctly. And to make this actually work correctly, what we have to do is we're going to have to add a special method to the item class. And that method is called the toString method. It's a method that takes no parameters and it returns a string to you. And if the class does in fact have a toString method and you hand one of those objects off to println, what println will do is it will turn around and call the toString method in that object, telling it to convert itself to a string, and then it will print that string for you. Right? So as long as there is a toString method somewhere in the item class, this code will do the right thing, and this will end up properly printing each one of the items that we have in stock. Okay, so that's the last of the methods that need to be written in the inventory class. And again, what we just discovered here by writing main is we've discovered the need for 3 major methods: add items, remove items, and print report. And along the way, as we wrote the code for these individual items, we discovered the need for some additional helper methods. So I also put in the code for the helper methods into the inventory class. All right, so the inventory class is now complete. We've finished the work of writing all of the methods that this class will need to do its work. Okay, so any questions at this point about what goes into the inventory class? Okay, now the last thing that we're going to need to do is in the course of writing all of these methods for the inventory class, along the way, I discovered a whole bunch of methods that will need to go into the item class. Right, here's some examples: increase quantity, decrease quantity, is none left, is my name. So if you've been keeping track, I basically have made up a wish list of a great big long list of different methods that the item class will need to have. So the final piece of work in the top-down design process is to write the code for each one of these methods that I have identified in the item class. All right, so here now is the item class with all of those additional methods added to it. And the good news is, for the most part, each one of these methods is very short and simple. Each one is designed to do a very specific and very simple task. For example, the isMyName methods. The way it's going to work is you're going to give it a name, and the question we're asking here is this name the same as the name of the item? All right, and for that, we just need a simple if statement. When you say this.name, you're actually referring to the member variable, which is right up here. And what I'm going to be asking is that member variable equal in value to the name that we've just been given? And if they are equal, we'll return true. Otherwise, we'll return false. All right, the other methods are even simpler. The isNoneLeft method, that simply takes a look at the quantity, which is stored in this member variable. If that quantity is 0, it'll return true. Otherwise, it returns false. All right, and the methods for increasing and decreasing quantity are also very simple. They both just change the value of the quantity member variable, either increasing it by n or decreasing it by n. That's all the work that they have to do. All right, and finally, if you want to be able to print your item objects by handing an item object off to the println command, for that to actually work, you have to add a specialized method that looks like this. It's called the toString method. And what it's supposed to do is it's supposed to return a string that has useful information in it. All right, and we're going to construct that string basically by gluing together several pieces of information that we have. We have a name, which is the name of the item. We also have a quantity. And by gluing together the name, a colon, and the quantity by using a concatenation operation, we can assemble a string that has all of the relevant information in it. and that's what the toString method will return. Right? So anytime you take an item object and pass it to the print line command, it will call this method. This method will put together some text, and then finally the print line method will print that text for you to see. Okay, so any questions about the item class and the methods that I've added to the item class? Okay, and then the last thing for us to do is to simply demonstrate that this all works. Remember, we have an input file here which has a certain number of items in stock. When we run the program, it will process all of the information in that file and then spit out a report at the end of the day saying how much of each item that we have at the end of the day. And if you want to check that this is correct, you can simply go through the original data in the text file and confirm that what's being spit out here at the end looks right. For example, the text file says that we started the day with 52 cases of apples in stock. The only thing that happened with those apples is that over the course of the day, we shipped out 10 cases. So then the report at the end of the day says we have 42 cases left at the end of the day, and that's correct. And you can confirm the same for all of the other items that are listed here in stock. Everything here ends up with the right quantity at the end of the day. All right, so success. We now have a complete program that does everything that we want it to do. Okay, so that is the top-down design process. Always begins by writing the code for the main method. Then along the way, we discover the need for methods. Then we start writing the code for those methods. Then in turn, very often as you're writing the code for each of these methods, you'll discover additional methods that you need. And at the end of the process, after we have written all of the methods that we've discovered the need for, then we have a complete program, and the only thing left to do is to run it and test it and clear up any bugs that were created during the writing process. Right, so this is the top-down design process. Right, now, an important thing to note about this is this process operates essentially in reverse from what most of you have been used to doing up until this point. Up until this point, most of you have been following what is essentially a bottom-up process where you actually start by writing the methods, and then after you've written the methods, you then write the code for the main method. Eventually, what we're going to get you folks to do is to sort of flip that process on its head and instead start with the main method, write that first, discover the need for methods that you're going to need, then go to work on writing those methods and work your way down through the process, essentially going in the opposite direction from what you're used to doing. Okay, now again, because this is a whole new way of thinking about programs and a whole new way of approaching the process of writing a program, obviously what we're going to need to do along the way is we're going to need to have some lab exercises that allow you to practice this process. And those lab exercises are coming in the weeks to come. All right, but before we can get to a lab exercise that does something even as close in complexity as this example, what we actually need to start with is an initial lab that focuses just on the very basics of writing and working with objects. And that's the lab that we're going to be doing next week. In that first lab, we're going to be dealing with some very simple objects, and we're going to be writing some fairly simple code to work with those objects, just so you folks get your feet wet in the process of creating and using objects. And then later labs, which will also focus on the use of objects, those later labs will be using this top-down design process that I've shown you here. And by the time you get to those labs, you'll have seen a number of examples where we build programs in this way, and hopefully that will start to become a more natural process for you as we get deeper into the course. And finally, one last bit of business is, as always, I have posted a programming exercise for you. As you'll see when you look up this programming exercise at the end of chapter 9, is that the goal of this exercise is to construct one very simple class and then to write a short and simple program that uses that class. This will start to give you some practice in writing and using objects. And this, if you like, this is a little bit of a warm-up exercise for you to do before we get to the lab next week, which will also have you working with objects. Okay, so with that, you folks now have quite a lot of stuff on your plate. You have several lectures that you'll need to go back and review. You have this programming exercise to work on over the weekend, and next week you'll have a lab focusing on the use of objects. All right, so more than enough stuff to keep you busy for the time being. All right, so have a good weekend working on this assignment and reviewing the lecture notes and doing the reading. We'll see everybody back here again on Monday.
Thank you.
Bye-bye.